So for next example, it is methane. For methane, it is 1 carbon and 4 hydrogen. CH4 is the methane. So for carbon belongs to group 4. As carbon belongs to group 4, so carbon has 4 electrons in its last shell. So there is a carbon nucleus having proton and neutrons in it, and there are 4 electrons in the last shell of carbon, as carbon belongs to group 4. Group number tells us the number of electrons in the last shell. So carbon has 4 electrons, and carbon needs 4 more electrons to complete its octet. And carbon will make 4 bonds. Carbon will contribute 4 electrons in its bond formation to get its octet. So hydrogen is having 1 electron. Each hydrogen need 1 more electron to complete its duplet to get like last shell electronic configuration of helium and to get its duplet. So each hydrogen will contribute 1 electron. So hydrogen will share its 1 electron with carbon, so there is 1 electron sharing. So there is a mutual sharing of 1 electron between carbon and hydrogen. 1 electron is further shared between hydrogen and carbon, and 1 more electron from carbon will be shared with the 1 more electron of hydrogen, and this electron of hydrogen and this electron of carbon will be shared between carbon and hydrogen. In this way, 4 covalent bonds are formed. 1 covalent bond, 2nd covalent bond, 3rd covalent bond, and 4th covalent bond. And when we count for carbon, it's 1, 2, 3, 4, 5, 6, 7, 8. So carbon has completed its 8 electron, completed its octet, has got the electronic configuration like the noble gases, and has got stability. And each hydrogen having 1, 2, 2 electron has completed its last shell electronic configuration of noble gases like helium, and has completed its duplet and has got stability. And you know that is a basic motive behind stability. Stability is the basic motive to form bonds. And each hydrogen has completed its duplet, carbon has completed its octet, and there are 4 single covalent bonds. So there is a 1 pair of electron. 1 pair of electron mean a single covalent bond. So that is a single covalent bond between carbon and hydrogen. That is another single covalent bond between carbon and hydrogen. This is a 3rd single covalent bond. This is a 4th single covalent bond. That can be shown like this way, that these 2 electrons, mutual sharing of electron will give a single covalent bonding. This is a mutual sharing of electron between carbon and hydrogen. This is a mutual sharing of electron between carbon and hydrogen, and this is the mutual sharing of electron between carbon and hydrogen. 1 pair of electron means single covalent bond. So single covalent bond is shown by 1 bold line. So 1 bold line, and the 2nd bold line, 3rd bond line, and the 4th bond line. So there are 4 single covalent bond between carbon and hydrogen. So carbon has 4 electrons in its last shell, so carbon needs 4 more to complete its octet, so it will make 4 bonds that you have seen. And hydrogen is having 1 electron, it needs 1 more electron, so hydrogen will just need 1 more electron, so will make a single covalent bond. Each hydrogen will make a single covalent bond, carbon will make 4 bonds. So there is the carbon with its nucleus having proton and neutron, and hydrogen with the proton. So this is the electronic cloud come between the carbon and hydrogen nuclei. So they will attract each other. So the proton of carbon, the proton of hydrogen will attract the electronic cloud lying between carbon and hydrogen that will bind them together, and will make that bonding between carbon hydrogen, and as it is the bonding formed by the sharing of electrons, so it is a covalent bonding. So the one covalent bond, the second covalent bond, the third covalent bond, and the fourth covalent bond, this is for carbon and this is for hydrogen. This is having a tetrahedral shape, tetrahedral structure, and these molecules, the covalent molecules, have definite shapes because these bond lengths are definite and the covalent bonds are directional, having their own direction. So the covalent molecules have definite shape because they have the definite bond lengths and they have the definite directions. So the methane shape is the tetrahedral shape. Carbon is coming in between, carbon is coming in the middle, and the hydrogens are taking the four corners, and therefore this is the tetrahedral shape. For carbon dioxide, carbon belongs to group 4. Carbon is having 4 electrons in its last shell. Carbon needs 4 bonds. It is having 4 electrons, it needs 4 more electrons, so it will make 4 bonds. Oxygen belongs to group 6. When oxygen belongs to group 6, it is having 6 electrons in its last shell, 1, 2, 3, 4, 5, 6. So oxygen needs 8 electrons. To get 8 electrons, oxygen needs 2 more electrons. So each oxygen will make 2 bonds, and carbon will make 4 bonds. So carbon will become in the middle, and oxygen will be on the sides, and each oxygen will need to make 2 bonds because it is having 6 electrons. It needs 2 more electrons to complete its octet. Each carbon is having 4 electrons. It needs 4 more electrons to complete its octet. So each carbon will make 4 bonds and oxygen will make 2 bonds. So you see, oxygen is making 2 bonds and carbon is making 4 bonds. On this side, carbon is making 2 bonds. On this side, carbon is making 2 bonds. And on both sides, oxygens are making 2 bonds. So one pair of electron and the other pair of electron between oxygen carbon mean there's a double bond, double covalent bond between carbon oxygen. And here there are 1, 2, one pair of electron and the 1, 2 another pair of electron. So the double pair of electron, double covalent bonding between carbon oxygen. So there is a double covalent bonding between carbon oxygen on this side, double covalent bonding between carbon oxygen on this side. So there is carbon making 4 bonds, each oxygen is making 2 bonds. So there one pair of electron, another pair of electron. So there is a double covalent bond between carbon oxygen, and 1, 2 and 1, 2 double covalent bond between carbon oxygen. And this structure is a linear structure. Oxygen will go on one side of the carbon and the second oxygen will go on the other side of the carbon, where the carbon is in the middle, and in this way this bond angle is 180 degree, and this is a linear structure. The carbon nucleus is coming in the middle, and this electronic cloud double covalent bond between carbon oxygen shown by 2 lines, and similarly the second oxygen is having the double covalent bond. So the proton of the carbon and the proton of oxygen will attract the negatively charged electrons coming between them, and that is how this is a binding force between them. And in this way, because this binding force is produced because the electrons are coming between the 2 nuclei by the sharing of electron, so it is a covalent bond. And in this way we know that carbon dioxide is having covalent bonding between carbon oxygen double covalent bond and the carbon oxygen double covalent bond. So double covalent bonding and double covalent bonding. And this carbon belongs to group 4. It needs 4 electrons to complete its octet because it needs more bonds. So it will become it will come in the middle. So that atom will come in the middle, which needs more bonds to get octet. Oxygen needs 2 bonds, so these bonds are lesser than the bonds required for carbon. So carbon needs more bonds, so carbon will come in the middle, and oxygen needs less number of bonds as compared to carbon, so it will come on one side. Very similarly, I can repeat my point of view. In case of methane, carbon needs 4 bonds, so carbon will come in the middle, and hydrogen just needs 1 bond to complete its duplet, so hydrogen will come on one side. So remember this thing, that it should not be confusing for us that which will come in the middle and which will go on the sides. That atom will come in the middle, which need more bonds, and that atom will come on the sides, which need less number of bonds. So this was for carbon dioxide. Each carbon has completed its octet to make 4 bonds. Each oxygen has completed its octet to get 8 electrons and has made 2 bonds. And in this way, both of them have got stable electronic configuration like noble gases and has got stability. For water, one of the very important compound here with us, and water, we know that it is made of 2 hydrogen atoms and 1 oxygen atom. Oxygen, as oxygen belongs to group 6. When oxygen belongs to group 6, it is having 6 electrons in its last shell. Oxygen is having 6 electrons. It needs 2 more electrons to complete its octet. Each hydrogen is having 1 electron. Each hydrogen just needs 1 more electron to complete its duplet to get the stable electronic configuration. So oxygen having 6 electrons, and it needs 2 more electrons, so oxygen will make 2 bonds. Each hydrogen is having 1 electron. It needs 1 more electron to become like the helium to get its duplet. So it just needs 1 bond. It just needs 1 more electron to complete its duplet to get 2 electrons. So it just makes single covalent bond. So their oxygen, so 1 electron is shared between hydrogen and oxygen, and 1 electron is more shared between oxygen and hydrogen. So if you count the number of electrons for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So this is for oxygen. For hydrogen, 1, 2, and this is for hydrogen, completed its duplet. This hydrogen, 1, 2, it has completed its duplet to get the last shell electronic configuration like hydrogen. For hydrogen, helium, and for oxygen, neon. 1, 2, 3, 4, 5, 6, 7, 8, and we know that the shared electron are counted in both of them, of the atoms sharing the electron. So there is a oxygen nucleus, there is hydrogen nucleus, and the electrons are coming in between. Similarly, oxygen nucleus and hydrogen. So hydrogen nucleus and the oxygen nucleus attract this shared pair of electron, and oxygen nucleus and oxygen nucleus and hydrogen nucleus share. There is a shared pair of electron between them, and they attract this pair of electron, and that bind the water molecule together, in which oxygen and hydrogen combine together to give us H2O. And we can show it like this way. There is one shared pair of electron, there is 1 more shared pair of electron. So there is a single covalent bonding between oxygen and hydrogen. There is 1 more single covalent bonding between hydrogen and oxygen. Single covalent bonding is shown by 1 bold line. So single bold line, a single covalent bonding between oxygen, hydrogen, oxygen, hydrogen. So there is oxygen and hydrogen. Oxygen nucleus is, and the hydrogen nucleus attracting this a pair of electron. This is pair of electron lying between oxygen and hydrogen, and oxygen nucleus having proton and hydrogen nucleus having proton. Protons are positive and electrons are negative. They attract each other. That force of attraction will bind them together because electrons are coming between the two nuclei and because of the sharing of electrons. So this is a covalent bonding in case of water. And to sum up, atoms need to get stability to get the last shell electronic configuration like the noble gases. Sometimes it is possible to completely transference of electron. Because of the complete transference of electron, one atom give away its electron, the second atom gain electron, so that because of the complete transference of electron, because of the loss or gain of electron, the bonding formed is called ionic bonding. The atom which is giving away electron will get a positive charge, it will become a positive ion, and the atom which will receive electron will get a negative charge, will become a negative ion. So in case of ionic bonding, ions are formed, and one is a negative ion and one is a positive ion, and positive and negative ions attract each other. So that is the base of the ionic bonding. In case of a covalent bonding, I'm just comparing so that you must get the last bit of the clarity about the ionic and covalent bonding. In case of covalent bonding, there are atoms, there is a sharing of electron, there is not a complete transference of electron. So the atoms when join, we get molecule. So in case of covalent bonding, molecules are formed. In case of ionic bonding, ions are formed, and these ions are attracted because they have the opposite charges, and we get a formula unit, which I shall describe in the next topics, that what I mean by when I say formula unit. And that is for the ionic compound, these are the ions, and in the covalent bond, the atoms will join to give us molecule. And these atoms, ions and molecules are very important. Most of the time in chemistry, we are dealing with atoms, we are dealing with ions, we are dealing with molecules. So by the ionic bonding and covalent bonding, we know very well that how atom has been converted into ions and how the atom has been converted into molecules. So in this way, we shall evolve our chemistry to the next topics, and my next topic will be on the macromolecules having covalent bonding, the giant covalent molecules. All this we discussed, that H2, O2, N2, Cl2, water, and methane and carbon dioxide gas. These are called simple covalent molecules. In my next topic, I would like to differentiate and will talk more on what I mean by when I say simple covalent molecules and what I mean by when I say giant covalent molecules and macromolecules, and this will be my next topic.